Welcome back to the Prompt Index. I'm your host, guiding you through the latest in AI research with a podcast-friendly lens. Today, we dive into a bold, data-driven question. When developers lean on AI to write code, how secure is that code in the real world? Problem and question. The study asks, across public GitHub repositories, how prevalent are security vulnerabilities in AI-generated code? And do vulnerability patterns depend on programming language or on the AI tool that generated the code? Methodology in depth. The researchers analyzed 7,703 files explicitly attributed to four prominent AI tools: ChatGPT 91.52%, GitHub Copilot 7. Amazon Code Whisperer and 0.52%, Tabnine 0.46%. They used CodeQL static analysis to identify common weakness enumeration (CWE) vulnerabilities, mapping to 4,041 CWEs across 77 types. Attribution relied on explicit comments and specific search terms, by, with, use, used, usings, from, paired with tool names, limited to English and to executable code in languages CodeQL supports. After a multi-stage filtering process, deduplication, removal of multi-tool attributions, non-executable content, and a 150-byte minimum, the final vulnerability analysis covered 7,696 files and 1,136,725 lines of code across Python, JavaScript, and TypeScript. They linked CWEs to CVs via the NVD and evaluated severity with CVSS v3.x. Key findings and implications. The study found 4,241 CWE occurrences across 861 vulnerable files, while 87.9% of analyzed AI-generated code did not contain identifiable CWE vulnerabilities. Language matters. Python showed higher vulnerability rates, about 16.18 to 18.5%, JavaScript around 8.66 to 8.99%, and TypeScript roughly 2.5 to 7.14%. Security density varied by tool and language. GitHub Copilot achieved better density for Python, 1,039 lock per CWE, and TypeScript, 905 lock per CWE, while ChatGPT led for JavaScript, 932 per CWE. In terms of volume, ChatGPT dominated the dataset, with the majority of vulnerable files coming from Python code generated by ChatGPT, 94.9%, whereas Copilot contributed a smaller but non-trivial share. The analysis also highlighted 39% of files used for documentation generation, underscoring AI's dual role in development and maintainability. Limitations and future work. Attribution-based sampling likely undercounts AI-generated code in the wild. Static analysis cannot catch runtime or logical vulnerabilities, and results reflect a snapshot in early 2024 with uneven sample sizes across tools. The authors call for longitudinal studies, controlled experiments, and exploration of language and tool-specific security mitigations. Conclusion and impact. The work shows AI-generated code is not uniformly insecure, but language characteristics drive vulnerability patterns more than the tool itself. It invites language and context-aware security practices, governance around AI-assisted development, and targeted review procedures to safely integrate AI-generated code into real-world workflows. Thanks for listening. If you found this valuable, please like and subscribe to our channel. To advance your AI knowledge further, check out our free resources at the Prompt Index. You'll find the link in the description below. Until next time.